Let us do some problems to prepare ourselves for the midterm examination. Question number 1, type the values in one single column. So this is the data, 164, 141, etc. So type this here. And it says use data analysis. Now where is data analysis? Come to data, then there is data analysis here, and there is descriptive statistics here. Say okay to that. Then you have to say where the data is. It is already selected from. So if you are not selected, then you can choose this and come here, and this is the data. It's grouped by columns because we have put it in one column. Now, what do you want? I want this one. I have to click summary statistics, and where is the output to come? I will choose a new worksheet because I already done it once here. I do not want to override that. The new worksheet, if I choose, let it tick there. New worksheet. This is a new workbook. It is not part of this sheet, something else totally. So I'll say new worksheet. Then I say OK. So it creates a sheet 2 with all the things that I want as descriptive statistics. That is mean, median, mode, and also standard error, standard deviation and variance, kurtosis, skewness, range, minimum, maximum, sum, and count. All those things are available. That is the answer to the first question. What is the type of kurtosis it is? Kurtosis is written here 3.67, etc. Otherwise, you have to use a formula is equal to kurt and show the data here. That would have given the same kurtosis. Because I use a descriptive statistics, see this same. And instead of kurtosis, if I wanted skew, all I have to do is change this kurt to skew. And I would have got 1.61 and same 1.61 is there. So I don't need this because already here. Kurtosis is 3.6 and it is. Let us do some problems to prepare ourselves for the midterm examination. Question number 1, type the values in one single column. So this is the data, 164, 141, etc. So type this here. And it says use data analysis. Now where is data analysis? Come to data, then there is data analysis here, and there is descriptive statistics here. Say okay to that. Then you have to say where the data is. It is already selected from. So if you are not selected, then you can choose this and come here, and this is the data. It's grouped by columns because we have put it in one column. Now, what do you want? I want this one. I have to click summary statistics, and where is the output to come? I will choose a new worksheet because I already done it once here. I do not want to override that. The new worksheet, if I choose, let it tick there. New worksheet. This is a new workbook. It is not part of this sheet, something else totally. So I'll say new worksheet. Then I say OK. So it creates a sheet 2 with all the things that I want as descriptive statistics. That is mean, median, mode, and also standard error, standard deviation and variance, kurtosis, skewness, range, minimum, maximum, sum, and count. All those things are available. That is the answer to the first question. What is the type of kurtosis it is? Kurtosis is written here 3.67, etc. Otherwise, you have to use a formula is equal to kurt and show the data here. That would have given the same kurtosis. Because I use a descriptive statistics, see this same. And instead of kurtosis, if I wanted skew, all I have to do is change this kurt to skew, and I would have got 1.61, and same 1.61 is there. So I don't need this because already here. Kurtosis is 3.6. Here the kurtosis is 3.6713, etc. In order to find out whether it is lepto, meso, or platy, we have to subtract 3 from here. And if after subtracting 3 from here, its kurtosis is minus 3. In this case, it is 0.67, that is positive. In such cases, when the kurtosis minus 3 is positive, then it is leptokurtic. So this case, it is leptokurtic. But if case it is almost equal to 3, nearly equal to 3, then it is called normal distribution. And if it is negative, this kurtosis value minus 3, if it is negative, then it is called platykurtic. In this case, it is leptokurtic. Skew is also positive. So it is a positively skewed. Another name for positively skewed is right skewed. Right skewed means the tail is to the right. And if I create a histogram, you can see that the tail is to the right. So that is answer to the question number 2 and 3. Coefficient of variation. Coefficient of variation for the above data is defined as standard deviation by mean multiplied by 100. Now, standard deviation I highlighted here 55.85, that is B22 divided by B18. So multiply standard deviation and then put a bracket there because you're multiplying the result of this division into 100. Otherwise, 100 will be the denominator. So B22, B18 should be enclosed in a bracket, and then the result has to multiply 100. That comes to 32.64 is answer. Coefficient of variation. Person drives 100 kilometers at 60 kilometers and further 100 kilometers to at 80 kilometers. Such problems are solved using harmonic mean. So harmonic mean, harmean. So the formula here is harmean, 60 and 80. The only thing I have to remember is that the distance has to be same. It is 100 kilometers there and 50 kilometers here. This harmonic formula will not work in such cases. The distance has to be same. Then only you will get. So 68.57 kilometers per hour is the average speed. And you can verify that by saying, okay, 100 kilometers at 60 kilometers, how much time you took? 100 kilometers, 80 kilometers, how much time you took? Total distance, 200 kilometers. Time taken here plus time taken here. So 200 kilometers divided by the time taken each of this. If I have to put it this way, is equal to 100 plus 100 is the total distance covered. And that is the distance covered. Time taken for the first leg is equal to 100 by 3. Time taken for the second leg is 100 by 80. The total time taken is equal to sum of these two. Sum of these two. So average will be is equal to the total distance traveled divided by the time taken. That comes to exactly 68.5. So instead of going through all these steps, harmonic mean does it in one go. I can remove this one from here. Company grows at the rate of 12%, 11%, 16%, etc. for 5 consecutive years. So when this growth is to be average, then you use a geometric mean. And how it is done? So we have 1 point, this is 12% means 1.12, 1.11, 1.16, 1.17, 1.1. So take a geometric mean of these things, and then you have to subtract the 1 from this. So that will be the CAGR, compounded annual growth rate. That comes to by using this formula. 0.13 means 13.16 here. So that is question number 6. Now let us see the section 2 here. Die is thrown at random. So these are the questions. I repeated the questions here. A die is written in red font. A die is thrown at random. What is the probability of getting a prime number? Now, what are the prime numbers between 1 and 6? 1, 2, 3, 4, 5, 6. Prime numbers are 2, 3, and 5. So there are 3 prime numbers. Total possibilities are you can get 1, you can get 2, you can get 3, etc. You can get 6. So 6 possibilities are there. 3 are my favorable things because that's what I want. I want prime number. So answer is 3 by 6 or is equal to 1 by 2. Coin is flipped twice, probability of both flips resulting tails. Now, 1 by 2 is the probability of getting ahead in the first one. I had a mistake here, so I changed the question itself. Probability of getting ahead, probability of getting a tail. We are looking for tails. Tails, tail. And probability of getting a second tail, second flip is also 1 by 2. So if I want to get both tails, the answer is same whether you are talking about head or tail. Because the question is talking about getting tail, here also adds to 1 by 2 and 1 by 2. And whenever I say I want this, also this and this, it is not this or this. So whenever and is there, you have to multiply the probabilities. So 1 by 2 and 1 by 2 is multiplied, it comes to 1 by 4. A card is drawn from a standard deck. What is the probability that it is either a queen or a heart? Deck has got 52 cards. And there are 4 queens and 13 hearts. Now, heart also has got a queen. So you can't count queen here also and queen here also. So we have to have 4 plus 13. And because you are counting queen in both the places, 1 has to be subtracted. So 13 plus 4 minus 1. This is the favorable outcomes. Total card 52. And therefore answer is 16 by 52. 2 cards are drawn from a deck without replacement. What is the probability that both are aces? Now there are 4 aces. Probability of getting the first ace is 4 by 52. Probability of getting the second ace, now we are 1 ace already gone. So there are 3 aces. One card is also gone. So 51 cards, so it is 3 by 51. And because we want both, it has to be multiplied. So 4 by 52 into 3 by 51. Ensure that you put the brackets properly. So you are taking one probability is 4 by 52, another probability 3 by 51. Those two probabilities are multiplied because you want both of them. And that comes to 0.0045. The bag contains 5 red. These are 5 red, 4 blue, and 3 green. 2 balls are drawn randomly. What is the probability that both are red? Now, red balls, if you have to say, combinations can be 1 and 2 can be taken, 1 and 3 can be taken, 1 and 4 can be taken, 1 and 5 can be taken. Then with 2, 1 is not to be counted because 2, 1 is same as 1, 2. So 2, 3 can be taken, 2, 4 can be taken, 2, 5 can be taken. So total comes to 10 different combinations. So instead of, when it is 5 balls, you can count it. So for such thing, there's a formula in Excel, which is combination. Combine, how many balls are there? 5 balls. How many are taking at a time? 2 balls. So how many ways you can select 2 balls out of the 5 balls that comes from this combine formula? Ways to choose 2 red balls from 5 red balls. Way to choose 2 balls from 12 balls. The entire thing is in the bag. And I can choose 2 balls by using the formula combine 12, 2. So these are the possible combinations. These are the favorable combinations. So 10 is the favorable one. And 66 is the all possible combinations. So 10 by 66, that gives probability of choosing 2 red balls, 10 divided by 6. There are 60 men and 40 women in a factory. So we are choosing, 3 employees are selected at random. What is the probability? All selected employees, all men. 2 ways of doing it. Now, first of all, I'm selecting 3 from 60 people. So 3 men from 60 men. Combine 60, 3. 3 from total of 100. Combination of 100, 3. And this is my favorable. This is my possible. Divide G83 divided by G84. That is 34,220 divided by 16. You just give the formula and that comes to 0.12. Another method is, first you are selected one person. The male is selected 60 by 100 and he is out. So there are 59 men there. And number of people also is reduced by 1. So 99. And third one is 58 by 98. And since you want all 3 to occur together, it has to be multiplied. So 60 by 100, 59 by 99, 50 by 18, that also comes to 0.212. Bag contains 8 white and 4 blue. If 2 balls are drawn at random, find the possibility that different questions are there. Both balls are white. Ways to choose 2 white from 8 is combine 8 by 2. 2 balls from 12, because the total of 8 plus 4, 12 balls are there. So 12, 2. So first answer is 22 by 66.4242. Second question is both balls are blue. Ways to since two blue balls is combination because there are four balls here, four blue balls out of the two. I have select combine 4, 2, 6, and two balls that is same as this one 12, 2. So 0.0909. Third question is one white and one blue. Choose one white from 8, combine 8, 1. There are 8 whites. I'm choosing one of them. Choose one ball from 4, 4 by 1. Now we want both of them to occur together. I want one white and one white and one blue. So multiply. The answer is E106 into, you multiply the 8 into 4 divided by 66. 8 into 4 by 66. Or you can. Question number 8. Person tests positive for a rare disease. Please pause the video and read the question properly. Now we have to find out what is the probability of the person having a disease when the person has been tested positive. Because even though it is 99% reliable, it also gives false positive to 1% of the population. That is why we can't just depend upon this 90% reliability of the test. Bayes theorem gives the formula for that. P have disease, given that you are positive, repeat the same thing here, and then multiplied by P have the disease in the population. Repeat the whole thing into the denominator here, plus another P positive, no disease. P positive, instead of have disease, no disease, and P of no disease. Now fill up the data here. P positive with the disease present, that comes to 0.99 because it is 99% accurate when there is a disease. Multiplied by how many people have the disease is 0.1%, that is equal to 0.001 divided by, same thing repeated. Now P positive with no disease, that is 0.01 because it gives for 1% population, 1% is 0.01, gives positive results. But that is for the people who do not have the disease. Only 0.1 have the disease, that is 0.999%, 9.999, or 99.9% people do not have the disease. So the probability of people having no disease is this one. And you take this one, you get 0.09016. So even if it is true that it is 99% accurate, because it has got a tendency to give false positive to the large population, we have to take it with a pinch of salt. That is only 9% probability that the person has. So in that case, what doctors do is take a second opinion and a second. Then if that also comes positive, then the probability drastically increases. This is how you solve the rare disease problem using Bayes theorem. Separate